Hi, good day everyone. My name is Tan Carmen from Group MEMS 14. Today I will be presenting about the operational principle of MEMS thermal actuator and MEMS finite element analysis. The operating principle of the V-shaped linear MEMS thermal actuator is based on the actuation mechanisms of thermal expansions, in which the structural material, electrochemically deposited thick aluminum, is heated up by the Joule heating. Next, I will explain about the equation used in this research paper. First equation is the residual stress equation. This equation helps to calculate the internal residual stress that causes the film substrate combination to be bent at a certain magnitude. For the CTE difference equation, the CTE difference is being calculated as it relates to the internal stress differential caused by the CTE mismatch.
Hi, Assalamualaikum. My name is Muhammad Shukri bin Abdul Rahman. My metric number is 18103287, and I will explain about MEMS Pro fabrication simulation for the thermal actuator. For the layout, we have 5 components, which is poly 0, poly 1, hole, 0, meter, and meter 1. And inside the table, we have state the coordinate and width and height for the certain component for our thermal actuator. And for the material database, we have state the important parameter, which is Poisson ratio, gas density, thermal conductivities, specific heat, Young modulus for the silicon, which is poly 0, silicon dioxide, which is poly 1, platinum for the metal, and aluminium which is metal 1. As you can see in the figure, which is an example of the material database for our thermal actuator MEMS Pro fabrication simulation. Thank you.
Assalamualaikum and good morning. My name is Nur Shafiq Iman bin Nur Rahman. My metric number 1810311734. Today I will explain about the process, definition and 3D model. So firstly, as we can see here, the grey color represent for silicon substrate, followed by orange color represent for silicon dioxide. The third one, pink color, represent for platinum, and the last one, the turquoise color, represent for aluminum. This is our step-by-step process definition and 3D model. First one, substrate wafer, followed by sacrificial layer deposition, sacrificial layer outer edge, seed layer deposition, seed layer edge, anchor deposition, anchor edge, and sacrificial layer edge. This is our final 3D model and final cross section. Thank you.
Here comes to the MEMS finite element analysis. This part will display about the ANSYS engineering data, geometry, model, and setup. The analysis system applied in this project is thermoelectric and static structural analysis system. All of the material properties needed in this project is added into the engineering data, and the geometry is imported into the ANSYS geometry space claim. In the ANSYS model, all of the parameters that needed to be changed are inserted into the steady-state thermoelectric conduction and the static structural to analyze the total deformation of the material. After done setting up, here shows the figure of the mesh and input and boundary conditions.
Good afternoon, my name is David Good. We're going to present about MEMS finite element analysis. And as shown in this photo is our ANSYS solution and our structure diagram. And then for the first graph is total deformation as input force, which are using the force by 0.1, 1, 10, 100, and 1000 micron Newton, and this we are using the three thickness 1.0, 1.5, and 2.0 micrometer also. And as you can see that when the thickness is low, there is a high deformation, and the deformation will increase by the force. And then the second graph is total deformation with input voltage, which is you can see increased by linearly also, and the silicon is the best have a best deformation. And the last one is the total deformation with input temperature. We have two types, which is thickness, we as aluminum, the material. So as you can see, only the thickness has no effective affect the deformation, but the material will affect the deformation, and copper have the highest deformation and also the stable deformation. So that's all for me. Thank you.
Hi, my name is Chankani. I will present about the MEMS thermal actuator for campus sustainability. Energy saving is important in Malaysia and worldwide as an environmentally sustainable to overcome the energy management challenge. The energy efficiency helps reduce the greenhouse gas emission and reduce the demands for energy imports. The government is keen to develop solar energy as one of the significant source of energy in the country. The service providers such as Source Energy Company is developed to help owners to make their homes, office, and school or university become more efficient in order to reduce their energy bills and reduce the carbon emissions. They provide installation of solar panel and maintenance service. The energy management is a global environmental challenge. Improper energy management will create numerous issues such as increase the risks of climate change and higher the energy costs. A smart energy management is proposed by utilizing a MEMS thermal actuator. This smart city solution will create a higher rate of improvement in energy efficiency by optimizing energy consumption to conserve usage in buildings. Goal 7 is to ensure the universal access to affordable, reliable, and modern energy service. Increase substantially the share of renewable energy in a global energy mix. By installing the thermal actuator on a solar panel, it can give the panel the ability to track the sun by moving with the sunlight to maximize the amount of direct absorption. With the implementing of this device, the energy efficiency in the campus can be improved. That's all from me. Thank you.